For years, this cascading wall of digital slots was the perfect metaphor for AI image generation. You typed a prompt into a text box, pulled a lever, and blindly hoped the machine would give you what you wanted. Usually, it didn't. Look at this generated image. The lighting on the skin might appear photorealistic, but the model predictably fails at anatomy, giving the subject 7 fingers bending at impossible angles. Look closely at the side of that same mug. The text spells out coffee sport. This was a standard failure point, instantly breaking any sense of immersion. These errors happened because early models lacked a planning phase. They were simply guessing which pixels should go next to other pixels, based on statistical proximity, without an internal map of what a hand or a word physically required. Statistical probability turned the user into a gambler instead of a professional creator. The Google Gemini 3 ecosystem and its new image model, Nano Banana, address this randomness by changing how the model processes your intent. Nano Banana introduces a reasoning engine. Instead of immediately spraying pixels, it intercepts your text prompt in a sandbox to evaluate its logic. The engine then parses the instructions into discrete logic gates, assigning strict rules for lighting, geometry, and physical constraints before rendering begins. Injecting a thinking step into the pipeline replaces blind guessing with physical rules. It turns AI into a deterministic, reliable tool. To handle different types of creative work, the ecosystem is split into 2 distinct models. The first is the Flash model, built for speed, conversational iteration, and rapid prototyping. It uses a feature called semantic masking, where the AI identifies and isolates objects based entirely on your text. We can instantly teleport the subject to the base of the Eiffel Tower, or drop them into the vast scale of the Grand Canyon, all while keeping the person completely intact. With a simple text command, the standard sunglasses fluidly transform into a bright red pair. The face, the lighting, and the background remain static. You can see the model's contextual awareness in this generated image. We asked it to add a cat to the subject's shoulder. The model calculates the weight and the contact points, matching the deep shadows of the environment so the addition feels natural. Because of the processing speed, you can iterate immediately. If you don't like the cat, you can type a new command and replace it with an owl, and the model preserves those exact same physical contact points. By isolating and modifying elements using only natural language, semantic masking replaces traditional manual selection tools for the majority of digital editing tasks. The second brain in the ecosystem is Nano Banana Pro. This is the high-fidelity strategist that sacrifices raw speed to prioritize structural logic and precise typography. Before drawing the final image, the Pro model constructs a wireframe blueprint to establish strict geometric boundaries. Then, perfectly legible, multilingual text fills those boxes. The spelling is accurate and kerning consistent, resulting in professional-grade graphic design. That architectural planning also allows the AI to lock in a character's facial features and clothing, maintaining their exact identity even as you move them across different scenes and camera angles. Commercial work demands brand and narrative continuity. This planning-first approach provides the consistency that professional campaigns require. Directing the Pro model toward high-fidelity results requires a specific syntax known as the Mano Banana prompt formula. This animated diagram breaks the formula down. A successful prompt requires 5 specific variables: the subject, the context, the environment, the lighting, and the technical camera specs. Typing something simple like cute dog leaves too many blank spaces. The reasoning engine will fill those gaps with averages, resulting in a generic image. But when you define the exact millimeter of the camera lens and specify precise directional lighting modifiers, you strip away the AI's ability to guess. You force the model to behave like a piece of mechanical hardware. We applied the formula, specifying the deep, moody Rembrandt lighting seen in source image 5 and the highly textured equipment of source image 6. The result is a tightly controlled cinematic shot of a dog in a suit. Directing high-fidelity AI models relies on knowledge of real-world photography rather than a background in computer code. Nano Banana's reasoning engine works so well because it constructs internal understanding of 3D geometry rather than just mapping colors onto a 2D grid. Look at this generated video of a single light source panning across a textured surface. Because of that geometric awareness, the AI accurately calculates how the light physics should interact with the material, shifting the microshadows perfectly in real time. This means you can take an existing scene and completely relight it after the fact, specify a new directional source and color temperature, and the model recalculates the physical space. Moving away from 2D pixel spraying and toward 3D aware rendering solves the core problem of AI art. It adheres to the actual laws of physics. We have moved past using the prompt box as a magic 8-ball. We are now interacting with creative software in a highly structured, deliberate way. Your ability to articulate and direct logic now determines visual quality, replacing the need for manual dexterity with a mouse or a stylus. Your role has shifted. You are now a digital cinematographer, operating the Nano Banana ecosystem as your own fully equipped virtual soundstage. Take the 5-part formula we laid out. Define your subject, dial in your camera settings, and direct your own rigorous imagery. The slot machine has been dismantled and replaced by a professional camera. The only variable left to supply is your creative intent.